What we are wanting to do is put our mathematics skills to good use and create some logic that will power our line trace and so detect any ceiling mesh that may be sitting above the ceiling light actor. To make a start then, we will want to be inside the ceiling lights construction script, where we can drag out from the construction script execution port, type line trace into the search field, and then add a line trace by channel node to the graph area. Now, although not being used to affect the player character in any way at this time, this node and its associated functions are exactly the same when being used on any actor that we place in our level. As we have the locations already calculated then, and because we will need the current location of the ceiling light to be the start point for the ray, we will want to pipe our getWorldLocation vector output into the start input of our newly created line trace by channel node, which means we can now use the second half of our calculations and take the output from the vector plus vector node and pipe that into the end input of the line trace node. Just to recap what we have then, we have started from the scene root location, and then, having found out what the up vector is, we've travelled in that direction by our 100 units. We have then added that 100 units to the ceiling light's current location, so in this instance, its x and y values remain the same, but its z value will be 100 units more. This all now giving us the endpoint for our line trace. We will perhaps want to make sure that our flow is a little more bulletproof for debug purposes, and so, dragging from the line trace node's execution port, we will want to search for and then add a branch node. This just means that when we test with the blueprint open, we can easily see when each part of the blueprint fires. If the branch node is the point at which things break down, then we know that the line trace isn't hitting anything. And whilst this isn't an essential step as such, it is a good habit that I have gotten into in order to help me figure things out clearly on more complex blueprints. We will need to know if the line trace has hit something, of course, and so, taking the return value from the line trace, let's hook that up to the branch node's condition input. This just ensures that if the line trace node does return a hit, then it will pass the branch node test. It is also a good way to stop our blueprints from accidentally executing any code if the line trace fails to hit anything. In this exercise then, we have reinforced our understanding of the line trace node in Unreal, and have hopefully grasped that it can be used in a number of versatile ways. Indeed, this is true of most nodes in our blueprint arsenal, and so if we just put a little thought into how to use them, we can certainly have them recognize their full potential. This being why breaking down just what it is that we want to accomplish before setting off on the work is a really good idea, as it gets the creative mind in gear.